Hello, Honors Geometry students. This is Mrs. Kamenar. Welcome to our lesson on classifying polygons. Just as a reminder about educational videos, as you are going through and watching and recording your notes in your note packet, you will find it helpful to pause and rewind and do all those types of things in order to really engage in our learning today. Our essential question for today is, how can I identify polygons? And it's going to go along with learning target 1A, where I can precisely define geometric terms. So I have an entrance question to start getting us thinking about what we're doing in today's lesson. And it says, identify all relationships shown in the figure below. So what I would like you to do right now is please pause the video, write down all of the relationships that you can see there. Hopefully you can find 5 total as you're identifying. So pause and we will regroup. All right, so the first thing that you might notice is that this guy and this guy, they have a 1 tick mark. So I might say that AC is congruent to CE. Since it's a line segment, I can choose to do the little bars up above or leave them off. Next thing I might address are the 2 tick marks here, indicating congruent segments, and I can say that DC is congruent to CB, again, choosing to have those bars up above my segments or not. Moving on to what's marked up in green here, this guy here and this guy here, I could say that angle A is congruent to angle E. I can name this by 1 vertex letter because each of those vertices A and E are just joining 2 segments together. Cruising along, I can take a look at this half circle 2 tick mark piece. And since there are more than 2 line segments creating those angles, I need to use 3 letters. So I could say that angle ACD is congruent to angle BCE. Last but not least, I see these arrows hanging out. And arrows, remember, indicate parallel, so I can say that AD is parallel to BE. So those are the 5 different relationships that I can pick out in that figure based on the labelings. Okay, cruising along. Okay, so what we see here on the left-hand side are examples of polygons. On the right-hand sides are examples of things that are not polygons. So please pause the video and come up with the characteristics that you think make up a polygon. Okay, so hopefully you had a chance to pause the video, and here's a list of things that you may have come up with. A polygon has to have 3 or more sides, has to be a closed shape. So you'll notice here on the right-hand side, this shape doesn't come together to be fully closed in, so that one is not a polygon. Okay. We need to have straight edges or sides. Okay, we'll notice over here we have a curved semicircle piece, so that is not a polygon. It needs to have straight edges. And if you look over here on the right-hand side, you see this guy here where it's kind of crossing over itself. So the fancy way to say this is that each vertex or each corner of our shape joins exactly 2 sides. Okay. And then one more thing that I want you to notice is that all of these are 2-dimensional shapes. So a polygon has to be a 2-dimensional shape. One of the things that people oftentimes get confused about is the difference between a pentagon and a polygon. A pentagon is a specific type of polygon. And in fact, it's a polygon that has 5 sides. Okay. Cruising along then, next thing that I would like you to do, here's a whole chart of polygons based on the number of sides. So I'm going to have you see how many of these that you already know. On your test for this on your summative for this unit, I'm not going to ask you, all right, what is a 7-sided shape called? But I might ask you later on, find the sum of the interior angles of a heptagon, and you'll have to figure that out. So please pause the video and then we'll compare. All right, so a three-sided figure is known as a triangle. A four-sided figure is known as a quadrilateral. Oftentimes people are telling me that this is a square or a rectangle. Those are specific types of quadrilaterals. A five-sided figure is known as a pentagon. 6 sides is known as a hexagon. Seven-sided figure is known as a heptagon. I believe it's also referred to as a septagon. 8 sides is an octagon. 9 sides is a nonagon. 10 sides is a decagon. And these next two sound kind of goofy. The 11-sided figure is an undecagon. Think about root words. Un for uno, deca for decade, 1 and 10 together makes 12. Or 1 and 10 together makes 11. Next one, 12-sided figure is a dodecagon. Again, you can break that down. The prefix do or dos for 2, then the deca in there for 10. 2 and 10 gives us 12. There's lots of other figure names beyond this, but for this class we're not going to be super worried about it. So we might talk about an n-sided figure called an n-gon. So for example, if I have a figure that has 25 sides, rather than worrying about the specific name, I'm going to call it a 25-gon. Okay, cruising along. Okay, so there's 2 examples here to help us identify which ones are polygons and which ones are not. So please pause the video and talk about, figure out which one is a polygon and which one's not. Okay, in example number 1, hopefully you were picking out that A is a polygon. This one is the only figure that's closed, made up of straight edges, and each vertex joins exactly 2 sides. In example number 2, please pause the video if you haven't checked this one out yet, and determine the one that is not a polygon. Okay, in this instance, we're going to talk about figure C, the cube, and this one's not a polygon because it is a 3D shape, and we need to make sure that we have a 2D shape to talk about a polygon. All right, some more vocab as we go along. Next piece is a concave polygon. And with a concave polygon, we can connect 2 vertices outside of the figure. Okay, so an example might look something like this. Okay, so I have 2 vertices or 2 corners of my shape. I can connect those 2 and it makes kind of a cave-like shape. I can connect those 2 corners outside of my figure. The convex polygon, and I'm just going to cheat here and use notability to my advantage. A convex polygon, we can't connect 2 vertices outside the figure. So we get rid of that little inny piece, and this would be an example of a convex polygon. We can't connect 2 corners outside of the shape. All right, diagonals of a polygon. This is going to connect 2 non-consecutive vertices. So in other words, we're trying to connect 2 corners that aren't already connected. So here's one corner, here's another one. There's one pair of vertices that connect, and then here's another one. Okay, moving on to the next corner. Connect these and these. These are also diagonals. So I'm not going to ask you on a summative like how many sides does a pentagon have, but I might ask you how many diagonals can I connect in a pentagon. So you'd go around and find each of your vertices and decide how many different corners you can connect that aren't already connected. And then in this case, in our pentagon, there are 5 different diagonals. Okay. So take a moment. Example number 3 says how many diagonals can be drawn in a convex hexagon. So no little any shape for us there. Okay, so pause the video and see if you can determine. Okay, so here's a little trick for you. If you are ever having trouble drawing one of these figures, so a hexagon has 6 sides, so I'm going to start by drawing a light circle on my iPad. And a hexagon, that's 6 sides, so I could do 1, 2, 3, 4, 5, 6 dots or 6 points along the edge. And if I connect those, I'm going to end up with a 6-sided convex shape, and then I could erase. So this says how many diagonals can be drawn in a convex hexagon. So what I'm going to do is go around here systematically. So pause the video if you haven't already to determine how many diagonals you can cross or you can draw. So I would have 1, 2, 3, 4, 5, 6, 7, 8, and then 9. That's going to get all of them for me. I have 9 different diagonals that I can draw in a convex hexagon. All right, cruising along here, we're going to do some more vocab. All right, so when we classify triangles, one way to classify them or to talk about their characteristics is by their angles. Okay, if we are going to have an acute triangle, it's going to have all acute angles. And remember, acute angles are less than 90. So here's an example of an acute triangle. An obtuse triangle is going to have one obtuse angle. If it has more than one obtuse angle, we can't connect it as a triangle. We'll talk more about that later. Angles in a triangle have to add up to 180. Okay. In a triangle, if we have a right triangle, we have exactly one right angle. If we have more than one, that's going to add up to more than 180. Okay, so here's our right angle, and notice that I'm using a little box piece to show that I truly have a 98-degree angle. And last but not least, an equiangular triangle, equal meaning equal, angular meaning angle. We have all congruent angles, okay, or 3 congruent angles. So we draw this out, and if I want to show that I have 3 equal angles, I would do that half circle piece or the half circle dash. Another way I can classify triangles is by their side lengths. In an isosceles triangle, I have at least 2 congruent sides. I could have more, but I need to have at least 2. And the way I would draw this out is like this, showing that 2 sides are congruent. Equilateral, equal meaning equal, lateral, think lateral pass to the side. Equilateral is all congruent sides. Okay, in an equilateral triangle, I have all 3 sides the same length, and I would put dashes on all 3 of those. So, thinking back, an equilateral triangle has all equal sides, an isosceles triangle has at least 2 equal sides, so anything that's equilateral is also isosceles. But it doesn't work in the opposite direction. An isosceles triangle doesn't necessarily mean it's equilateral. Okay. Last but not least, we have a scalene triangle, and there are no congruent sides in a scalene triangle. So one way that you might choose to draw this out is like this, showing that all 3 sides are unequal by doing 1, 2, and 3 tick marks on each to show that no 2 are the same length. All right, moving along. Okay, so looking at example number 4, pause the video and decide which way you can classify it based on angles and side lengths. Okay, so I notice here that this is a 92-degree angle, so this means it is an obtuse triangle. Okay, I also notice that I have 2 sides that are marked as congruent, so that means it is also isosceles. Cruising along, I notice that I have a 116-degree angle, so that means it is an obtuse triangle. And then I notice that I have 1, 2, and 3 dashes on my sides for my triangle, so that means that no 2 sides are the same length, so this means it is a scalene triangle as well. Okay, my last example, pause the video, come up with 2 different ways to classify this one. I notice that all three angles have the same half circle, so that means it is equiangular. I also notice that the three sides are all the same length, so it would be equilateral. Since it's equilateral, I know it also has to be isosceles because it has at least two equal sides. Okay. One more term that I'm going to throw in here at you is if we ever come up with a shape that is equiangular and equilateral, we would say that this shape is regular. Regular means all equal sides, all equal angles. Okay, so that's going to do it for this lesson. So take a moment, reflect, what did you learn today? And then you're going to head on over to our link, and this is linked up in Google Classroom. You're going to complete the Classifying Polygons worksheet in Notability, and then upload it to Google Classroom. All right, please let me know if you have any questions. I'll see you in class. Bye.